Graphing quadratic inequalities in two variables is really not much more difficult than graphing linear inequalities in two variables. Of course, the key is that you have to be able to graph the quadratic function. So let's take a look at two variations of the same quadratic function. In one case, we've got y is greater than x squared plus 5x minus 14, and the other we have y is less than x squared plus 5x plus 14. So you want to be able to graph them, and if you can factor a quadratic, that tells you where it crosses through the x-axis, so that's a very useful way to get an idea of what the graph looks like. We of course know that this has a y-intercept of negative 14, because if you let x equal to 0, you can see that the y value is going to be negative 14. So if we factor this, we see that it factors as x plus 7 and x minus 2, which means that the graph of the parabola passes through the points on the x-axis at negative 7. The factor x plus 7 corresponds to an x-intercept of negative 7. And passes through on the positive side at positive 2. So we have these two intercepts here. And it's the same graph for both, obviously. But there's one thing I have done here that I've got to be careful about, because I look at the inequality, it's a strict inequality, and which means that the points on this parabola don't actually satisfy the inequality. They don't make it true. So I need to make this a dotted line, and you can do that whichever way you like. And since I'm doing the same graph, essentially, what I'm going to do is just copy this graph and paste it over here. So obviously it's a little easier for me. There are the two graphs of the quadratic function, but now we have to think about the inequality here. And if you have it written explicitly, meaning you've got y on its own on one side, then this is very easy. Y greater than just means above, so all of the y values above, and so the values here inside the parabola, if you like, but above the parabola, are the ones that are going to satisfy the inequality. And just like before, you can always pick points to test. The origin is the easiest point to test. The only reason you wouldn't pick the origin is if it passed through the origin, and this one clearly doesn't. So go back up to the original equation, original inequality, and plug in the origin, 0, 0. On the left you get 0, on the right you get 0 plus 0 minus 14. And since that's a true statement, 0 is greater than 14, we want the origin to be part of the solution and everything in that region. You can think of the parabola as dividing the plane into two regions, just like the line divides the plane into two regions, two half planes. Here it's not quite the same as being a half plane, but you can think of it as inside the parabola and outside the parabola, or above the parabola and below the parabola. So the only difference with this one and the one on the right is that on the right we have y is less than. Now again, if you were approaching this for the first time, you'd want to factor it and figure out where it passes through the x-axis. And then you're looking at all the y values that are less than, meaning all the y values that are below. And so it would be all of the ones below the parabola, which basically means everything outside the parabola, if you like. And this goes on forever. Now, if you're not shading the way I am with a highlighter, you can use arrows and just try to shade it in and indicate that it sort of goes on forever. Obviously, it's a lot easier if you can shade it in with a different color like I'm doing. And once again, the dotted line means that that shouldn't be part of the solution, because when you plug in values along the dotted line, you'll get the left-hand side equal to the right-hand side, and therefore the left-hand side is not less than the right-hand side. So let's just take a look at one other option. What if it doesn't pass through the x-axis? Well, you have to remember all of your skills for graphing quadratics. And let's take a look at one that's written in vertex form. So y is greater than or equal to half x minus 2 squared plus 1. So because this is written in vertex form, we can very easily identify the vertex. The vertex is 2, 1. And if you want another point, just to give you some reference, you can figure out the y-intercept just by making x equal to 0. If you make x equal to 0, in the brackets you get 2. When you square that, you get 4. Multiply that by half, you're back at 2. And add 1, you're at 3. So this passes through the point 0, 3. That's the y-intercept. So when we go to graph this, it doesn't pass through the x-axis at all because the leading coefficient is a half. That means it's facing up. And if it has a vertex at 2, 1, it's never going to cross through the x-axis. It's going to be a little wider because of that leading coefficient of a half. This point here we just identified as 0, 3. And this vertex here is at 2, 1. And we have a solid line here because this is y is greater than or equal to. So we do want to include the parabola itself. That will satisfy the inequality. And then since its y is greater than or equal to, we want all the y values that are above, which would correspond to all the y values sort of on the inside of the parabola. And that's kind of what the graph would look like. And the yellow area would sort of continue on forever going up. Now, of course, if you ever get stuck, and even if you're not stuck, you just want to explore, you should definitely try some graphing software. And I recommend Desmos. Let's see how that last one would look if we plug it in. So y is greater than or equal to a half, 1 divided by 2. We sort of get graphing as we go. Open bracket, x minus 2. It automatically enters the closed bracket when you hit open bracket. The exponent is just a to the b here. Square that. Hit enter again, or hit the click the mouse button so that you're not in the exponent mode, and then do plus 1. And you can see pretty much the same graph that I graphed in Windows Journal. You can see right there the y-intercept 0, 3, the vertex 2, 1, and the shaded region is the region above. It's a solid line because its y is greater than or equal to. So, really fairly straightforward as long as you're comfortable with your graphing skills of quadratics.